All right. So here's the start of the chapter 8 BC notes. We've already completed these, but as was requested during our chat, I'll do just a quick recap of each section. So section 8.1 was kind of a review of the past. It's actually, we learned some of this in chapter 5, just real briefly. So it's just a review of some different techniques. One of them you might remember, long division. Long division, remember, any time the top is the same power as the bottom or bigger, we have to divide first. We have to. I don't care what section we're in. So the top is the same. So I do long division. I divide the bottom into the top. Goes in once. And then 2x comes down, and x squared does go, we're already done. That's why I jokingly call it short division. So this integral turns into 1 plus remainder over so you can equate this to changing an improper fraction to a mixed. It's kind of like someone saying, hey, I got to deal with 11/3. Oh, that's 3 2/3. In calculus, we can't take the integral of this, but we can of this. And that's what's happening. I can't take the integral of this improper, but I can take a picture of this mixed. Okay? Take integral, whatever I said. So, all right, integral of 1 is x. Pretty simple. That's just a perfect natural log, top through the bottom. So ln of absolute value of the bottom. Now, since it's x squared plus 5, it can never be negative, so the absolute value was redundant, but it's okay to put it. And that's it. That's long division. That's what you do if the top, remember, if the top is tied or bigger, we divide it in, okay? All right, split. Split's kind of, when I know split is when I go, I could take the integral if that x was gone. I could take an integral if that 12 was gone. So we split into two problems. So I just go, oh, since they're both over x squared plus 9, I get to rewrite it. So it's kind of like, instead of getting a common denominator, we're just splitting them back. So now, the integral of that first one, 12 over x squared plus 9, I recognize that as arctangent. So arctangent, let me turn this a little bit. So arctangent is when, the top's not the derivative of the bottom. You can kind of see something squared, something squared. So we have the multiplier of 12. Remember, there's also 1 over a involved. Now the top has to be the derivative of x, which is 1, so nothing going on there. So it's just a 12/3 arctangent of x over 3. That will reduce down to 4. And then the last one is an ln, because all it's missing is a 2. So I'm just missing, for this integral, a 2, so I put a 1/2. You can't really see that, but it's 1/2 ln of x squared plus 9 plus c. So we split it into two integrals I can take. Real important, you can tell the difference between an arctangent and a natural log. Natural log, obviously the top through the bottom. All right. So we split it into two we could do. The last one was completing the square. Let me set that up. So we have our notes here. I haven't printed out. Let me get you So I look at this and go, it's not arctangent right now. It could be. It's not natural log. But if I can make this a perfect square, I can turn it into an arctangent look. Because an arctangent look is some number. You got something squared here plus something squared here. Usually this is a variable and this is a number. So let's see what we can do. So if you remember, I'll switch up colors there. We can add 9 to make that a perfect square. Remember, if we take half of 6 is 3, 3 squared is 9. And then I got to borrow the 9 from the 34. Because I can't just change a problem. So I need to use 9 of this guy and use it for this guy to make him a perfect square. So now we have it in a perfect arctangent. Now it's in that form that I want. So now it's arctangent. So we have a 2 for your multiplier here. You have your 1 over a. You have arctangent. Erase that. So ugly arctangent there, but so 2/5 arctangent of x minus 3 over 5 plus c. Okay. Now back over here, this one eventually becomes 12/3 is a 4, and that's it for that one. That's it. So if you guys remember completing the square, I can visualize, some of this might be in your 25-minute question. I'm not sure. So, but that's section 8.1.